Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic and combustion. And our subtopic for the day is testing other components of air. In the previous videos or in the previous lessons, we discussed on the active part of air. We said that air is a mixture of gases, contains a mixture of gases, and we were talking about oxygen being the active part of air. We were able to also test that active part of air with different experiments, and we came up with a few conclusions. So for today, we are going to be testing other components of air. Just like we said, the air contains other components, and then we are going to look at a few questions in regards to what we are going to discuss for the day. So first of all, when it comes to other components, we are basically talking about carbon dioxide, we are talking about water and how these components can be tested in the laboratory. So one of the things that we are going to discuss is the water vapor. So water vapor, one of the ways we can show evidence that they exist in air is the formation of dew, especially early in the morning. You notice some water droplets on leaves of different plants. This tells you that the water that is in air has condensed to form that dew because of the cool temperatures of the night. And then also, if we take anhydrous copper 2 sulfate, which is white in color, and you leave it open overnight, you notice maybe after a day that a blue solid is going to form. So the color is going to change from white to blue. This is because anhydrous copper 2 sulfate absorbs water moisture. And the moment it absorbs water moisture, it becomes hydrated. That's why we refer to the final compound as hydrated copper 2 sulfate. And then also sodium hydroxide, if you leave the pellets in open for a few days or overnight, you'll notice that it's going to form a colorless solution. So what happens is that the sodium hydroxide pellet absorbs the atmospheric vapor, water vapor, and then it dissolves it in it to form the sodium hydroxide solution. So if we continue looking at some of other compounds that absorb water moisture, another compound is anhydrous calcium chloride. This is usually one of the components that is used in the U-tube to dry gases. So if you passed some gas in a U-tube containing anhydrous calcium chloride, you notice that it's going to form a colorless solution. So the anhydrous calcium chloride usually absorbs water in the gases. So this is the equation. So the anhydrous calcium chloride reacts with water to form the calcium chloride solution, which is usually a colorless solution. And then also we notice that some of these solutions they usually absorbs water moisture from the atmosphere and they form a solution. These substances are referred to as the liquescent substances, which is a bit different from efflorescent substances. And the efflorescent substances are substances that lose their water of crystallization when exposed to the atmosphere. And then also we have another group of compounds called hygroscopic compounds. This one also absorbs water vapor from the atmosphere, but they do not form a solution. So it's a bit hard for us to be able to use them to show the evidence that water is in the atmosphere. So for this, the liquescent substances, they help us because they form a colorless solution. So we usually refer to them as the liquescent substances. And other substances that are the liquescent in nature are, we have the iron 3 chloride, we have the magnesium chloride, we have the zinc chloride also are deliquescent in nature. And then the other components of air we are going to discuss is carbon dioxide. So what are some of the evidences that carbon dioxide exists in air? So one of the evidences is the glass toppers in the laboratory. So if the glass toppers contains sodium hydroxide solution, they tend to stick after some time. The reason why they stick is because the sodium hydroxide reacts with carbon dioxide in air. When it reacts with carbon dioxide, it forms the solid sodium carbonate. Then this solid sodium carbonate is the one that causes the stoppers to stick because it's holding on to them. So the equation for the reaction is sodium hydroxide reacts with carbon dioxide to form sodium carbonate and water. This reaction was repeated when we were talking about the fractional distillation of air. We said that sodium hydroxide absorbs carbon dioxide in air. It can be used as one of the solutions to remove carbon dioxide from the atmosphere. And if we continue bubbling air in lime water, we said that bubbling air in lime water forms a white precipitate, and that white precipitate is because of the formation of the insoluble salt called calcium carbonate. This is actually the test for carbon dioxide that we discussed. So if the atmospheric carbon dioxide reacts with lime water as shown in the image, there is going to form a white precipitate. So if we look at the equation for the formation of the white precipitate, the calcium hydroxide reacts with carbon dioxide to form calcium carbonate and water. And this is the equation. You can see how we write calcium carbonate. And if you continue bubbling this air, even after we have formed the white precipitate is going to dissolve. So this experiment also is going to be repeated in Form 2 when we talk about carbon and its compounds. So what happens is that the calcium carbonate reacts with carbon dioxide to form calcium hydrogen carbonate. Calcium hydrogen carbonate is colorless in solution. So basically you take the product of the previous equation, which was calcium carbonate and water, you react it with more carbon dioxide. When you react it with more carbon dioxide, it forms the calcium hydrogen carbonate, which is shown in the equation. So when you look at the chemical equation, you can see what is happening. This is colorless in solution. So if we pick the white precipitate, we continue bubbling more air, it's going to turn from white precipitate into a colorless solution. That colorless solution is called calcium hydrogen carbonate, as you can see from the equation. So let's look at a few questions to help us to conclude this subtopic on the testing of components of air. So describe an experiment to show that carbon dioxide is available in the atmosphere. So we can use sodium hydroxide pellets. So sodium hydroxide pellets were left exposed for some days. So when they were left exposed for some days, they absorbed moisture and formed a solution. So this is the evidence that we have some water vapor in the atmosphere. And then the next question is to show how carbon dioxide can be shown in the atmosphere. So we bubble air in a test tube containing uh, calcium hydroxide, and after some time it turned into a white precipitate. So we know the white precipitate is as a result of formation of calcium carbonate, which is a white solid. So that brings us to the end on checking the components of air. Next, we are going to look at one of the major processes that happens, which is rusting. So watch out for that video as we discuss the rusting process. We did mention it a little bit in one of the videos when we were discussing the active parts of air, but we are going to take some time and discuss in details and also check what are some of the ways we can prevent rusting. So see you in the next lesson.